Hi, I'm Harold. Do you want to work from this office? Well, let's make sure you are comfortable Active Directory. To understand Microsoft's Active Directory, abbreviated as AD, we start with a top-level domain, TLD, also known as the last part of a domain name, such as .com, .net, or .org. There are several categories of TLDs, including generic TLDs, GTLDs, like .com and .net, and country code TLDs, CCTLDs, like .uk for the United Kingdom and .fr for France. The .com TLD is a GTLD that is intended for commercial use. It is the most popular TLD, and as such, it is often the first choice for businesses and individuals when registering a domain name. The 13 root DNS servers are a critical part of the Internet's infrastructure. They are the first point of contact for domain name resolution, which is the process of converting a domain name into an IP address that computers can use to communicate with each other. When you type a domain name into your web browser, your computer sends a request to one of the root DNS servers, which then directs the request to the appropriate TLD server. The TLD server then directs the request to the appropriate domain name server, which finally responds with the IP address for the domain name in question. This process happens very quickly, allowing you to access the website associated with the domain name almost instantly. A local file on a Windows machine that was used to resolve names to IP addresses before DNS was introduced, hosts file. All of these web pages are saved on a server as a host file. The hosts file is a simple text file that maps hostnames to IP addresses. It is used by the operating system to resolve hostnames to IP addresses, bypassing the need to use a DNS server. Before the widespread use of DNS, the hosts file was the primary way to resolve hostnames to IP addresses on the Internet. It was a simple text file that contained a list of hostnames and their corresponding IP addresses. When a user wanted to access a website, their computer would first check the hosts file to see if there was an entry for the domain name they were trying to access. If there was a match, the computer would use the corresponding IP address to connect to the website. If there was no match, the computer would try to resolve the domain name using other methods, such as sending a request to a DNS server. Nowadays, the hosts file is mostly used for testing and debugging purposes, or to block access to certain websites by mapping their domain names to localhost 127.0.0.1. It is also sometimes used to bypass DNS censorship in countries where access to certain websites is restricted. Website spoofing, also known as DNS spoofing, also known as DNS cache poisoning, is a type of cyber attack that involves injecting false DNS information into a DNS server's cache, causing it to return incorrect IP addresses for domain names. This can be used to redirect traffic intended for a legitimate website to a different, malicious website, potentially exposing users to phishing attacks or other types of cyber threats. DNSSEC, Domain Name System Security Extensions, is a set of security extensions to the DNS protocol that provide defense against DNS spoofing and other types of DNS attacks. It uses public key cryptography to digitally sign DNS records, allowing clients to verify the authenticity of the information they receive from DNS servers. DNSSEC works by using pairs of keys, private and public keys, to sign and verify DNS records. When a DNS server receives a request for a domain name, it first checks to see if the domain name is signed with DNSSEC. If it is, the DNS server retrieves the corresponding public key and uses it to verify the authenticity of the DNS record. If the record is verified, the DNS server returns it to the client. If the record cannot be verified, the DNS server does not return it, protecting the client from potentially malicious DNS records. DNSSEC helps to protect against DNS spoofing and other types of DNS attacks by ensuring that the information received from DNS servers is accurate and has not been tampered with. It is an important tool for ensuring the security and integrity of the DNS system. You are earning that corner suite office now. Are you ready to analyze different types of file permissions? Let's move on to NSLOOKUP. NSLOOKUP is a command line tool that is used to query the domain name system, DNS, to obtain information about a domain name or an IP address. It is available on most operating systems, including Windows, Mac OS, and Linux. One of the primary uses of NSLOOKUP is to obtain the IP address of a domain name. When you run NSLOOKUP and specify a domain name, it sends a request to a DNS server to resolve the domain name to an IP address. If the DNS server is able to resolve the domain name, it will return the corresponding IP address. NSLOOKUP can also be used to perform a reverse DNS lookup, which is the process of obtaining a domain name from an IP address. To do this, you would use the NSLOOKUP command and specify the IP address rather than the domain name. The NSLOOKUP tool will then send a request to a DNS server to resolve the IP address to a domain name. If the DNS server is able to resolve the IP address, it will return the corresponding domain name. NSLOOKUP is a useful tool for troubleshooting domain name resolution issues, as it allows you to query DNS servers directly and see the responses they give. It is also useful for finding out information about a domain name or IP address, such as the DNS server responsible for it, or the Mail Exchange (MX) records for a domain. We will finish our conversation here by discussing pointer records. A PTR record, pointer record, is a type of resource record in the domain name system, DNS, that is used to map an IP address to a domain name. It is used for reverse DNS lookups, which is the process of obtaining a domain name from an IP address. A reverse lookup zone is a special type of DNS zone that is used to store PTR records. It is organized in a way that is the reverse of a typical DNS zone, which maps domain names to IP addresses. Instead, a reverse lookup zone maps IP addresses to domain names. The purpose of a reverse lookup zone is to allow clients to perform reverse DNS lookups, which is a common operation used for a variety of purposes, such as verifying the identity of a server or troubleshooting network issues. When a client performs a reverse DNS lookup, it sends a request to the DNS server responsible for the reverse lookup zone, which then looks up the PTR record for the specified IP address and returns the corresponding domain name. In summary, a reverse lookup zone is a special type of DNS zone that contains PTR records, which map IP addresses to domain names. It is used to allow clients to perform reverse DNS lookups and obtain the domain name associated with a given IP address.